Alright, so page 2 is all about eliminating the parameter. After you eliminate the parameter is the t-value, then you also have to identify the shape. It's easiest probably to identify the shape once you get it into this form. So let's talk about the first one. The first one has sines and cosines in them. So with those, you have to make sure you remember we have some identities. So the one we should know is cosine squared of any angle plus the sine squared of that same angle always has to equal 1. So that's what you're working off of, that identity. So when I take the first part of the parametric, the x piece, to solve for the cosine so that I can plug it into that identity, I subtracted 1, I divided by 4, and so I found out the cosine of 2t was equal to this fraction. So I plug that in, x minus 1 over 4 squared for this piece. Did the same thing for the sine. I added 5, I divided by 3, so this is what the sine of 2t equals. So now I'm going to substitute that in my identity. So the cosine value squared plus the sine value squared equals 1. Now that 2t, if that's kind of bothering you, that is not affecting the rectangular part of this. It's not affecting the shape of it. What it is affecting is how many times it goes around the circle. So when you think of putting numbers in, like when we put in 0, we would still, even if it's 2t, we would still take the cosine of 0 here, and we take the sine of 0. When I put in something like, let's say, pi over 2, well, 2 times pi over 2 is pi, so instead of taking the cosine of pi over 2, it's already at pi. The cosine of pi, sine of pi. So really what's going to happen, when you go around all the way for t going from 0 to 2 pi, you actually would go from 0 to 4 pi when you go around the circle. So all that this would do, if you put this in your calculator and watched it, it would end up going around the same ellipse twice because of that 2t. But it does not affect this equation. So once you get it into this form, you should recognize that this is an ellipse. Its center has been moved 1 to the right and 5 down. Now maybe I should back up a little bit. How do I know it's an ellipse? It's an ellipse if there's a plus sign and both the x and the y's are squared. Then you know it's an ellipse. And in standard form, it's always set equal to 1, which is good because we're using that identity. It's always equal to 1. So once I have it in this form, I should see the center changes from 1 to -5. And then this is actually the stretch. Before you square that, whatever's underneath here, it just says, oh, the x's were stretched by 4 because it's divided by 4. The y's were stretched by 3 because it's divided by 3. So from the center, your ellipse is going to have 4 vertices. So when I go to think about what the key points of that ellipse are, the center comes from here. It got shifted 1 right and 5 down. The vertices come from the stretch. So from this point, I'm going to stretch the x's by 4 from a normal circle. Normal circle goes out 1. So now from the center, I go 4 to the right and 4 to the left. That's where these numbers come, these vertices come from. And then I'm going to go, because the y stretch is 3, I'm going to go up 3 and down 3 from the center. And that's where those vertices came from. So really for the quiz, just make sure you can eliminate the variable. That's the big piece. And then as much of this as you can give me. I don't think this will be worth a lot of points, but making sure you can get to this step is really what's coming out of this section. This is just a little bit of review, so it definitely won't be worth a lot of points on the quiz. All right, number 5. 5 is also a trig identity, so think of the trig identity, tangent squared of an angle plus 1 equals secant squared of an angle. So I solved the first part of the parametric for the tangent. I added 1 divided by 2. For the y, I subtracted 4, and then I just plugged in tangent squared plus 1 equals secant squared. Now with this one, again, if I want to get the 1 here by itself, I had to subtract this x plus 1 over 2 squared. So I subtracted that on both sides of the equation to get this equation. And again, that's the main piece of this. That can you solve each of them for their trig value, plug it into the identity you should know, and then get it into this form. After that, again, for minor points, do you know what's happening? The center, well, what happened to the shift of this one? The center will be at the y values getting shifted 4 up, the x values getting shifted 1 to the left. Remember, it's always opposite of what you see in a rectangular one. So it went 4 up, 1 left. The other thing you need to know is that this one is a hyperbola. Why? Because again, you have two squares. Both of them are squared, but now you have a minus sign. Anytime you have a minus sign and both are squared, after you set it equal to 1, realize, then you know it's a hyperbola. So the center, we've got that. With hyperbola, again, we aren't going to spend a lot of time on the, we're going to kind of cover this later, but for now, I just want you to know that where the center is. Let me just explain how you graph it, but again, I'm not too worried about this piece on the quiz, is that after that, I know where the center is, and again, we look at the kind of the stretches of it. The y's are just stretched by 1, so they don't really get stretched. So from the center, I go up 1 and down 1 to get to a vertice. And the x's are shifted 1 to the left, which means from here, or not 1 to the left, I'm sorry, I'm talking about stretches, I guess. The x's are stretched by 2, so I go 2 over and 2 to the right because of that 4, or that 2 right here, if you want to look at it there. And so if you remember from hyperbolas, we made a box, a rectangle. The diagonals of that rectangle kind of guided your two parts of the hyperbola. And so here's the one part going up this way, and the other part goes down. So these numbers here, the 2 and the 1, are what help you make this rectangle. Once you have your rectangle, now you have the guide of the hyperbola. But for our quiz, I would say recognize it's a hyperbola and be able to tell me the center. That's all you really would need for the quiz. All right, and then the last one, this one was just in terms of t, so I didn't really have to do anything with trig identities. So I took the first part of that, solved it for x, so I subtracted 3, or solved for t, sorry, subtracted 3, took the square root of both sides, don't forget the plus or minus, so I get t equals plus or minus the square root of x minus 3. So then I took that and plugged it back into this one. So I get y equals 3 times that t value minus 1. So if you took 3 times the positive of that, square root minus 1, I got this. 3 times the negative 1 times the square root of that gave me negative 3 times that square root of x minus 3 minus 1. So that plus or minus, just remember, you're still multiplying 3 times this. So you'll have a positive 3 and you'll have a negative 3. Now, what does that do, or what does that look like? You should realize that both of these are square root functions, moved 1 down and 3 to the right. So that's why it starts here at 3 comma negative 1. When I have the positive 3 times that, the 3 is going to stretch the y's by 3. So instead of going over 1 and up 1, it's going to go over 1 and up 3. That's where that point came from. So it's vertically stretching it this way. But then because of the negative piece of that is going to flip it over the x-axis. So now instead of going up, that shape is going to be here and going down with that same stretch. So it ends up being a sideways parabola when you put those two pieces together. So for that one, you should know it's a parabola. You could say it opens right. You should know that, and you should know where the vertex is of that. So that's kind of everything you need with that. The big thing is making sure that you can eliminate the parameter, and then when you get a function in terms of x and y, or I should say an equation, because sometimes they aren't functions, you should be able to tell me what that looks like. So with something like this, you should be able to tell me, yes, that is definitely a sideways parabola opening right with my vertex. You get that from looking at your two parent functions. If you have a hyperbola, as in number 2, just make sure that you can tell me that after you get it into this form, recognize it is a hyperbola and tell me the center of it. And then for an ellipse, again, it will always be when you have this sine squared and cosine squared. Once you get it into this form, you should recognize it's an ellipse you should be able to tell me what the center is. Because of the x stretch and the y stretch, you should be able to give me those 4 vertices of that ellipse. Now remember, if that would have been a circle, so let's say you would have had x minus 1 over 3 squared plus y plus 5 over 3 squared. That becomes a circle. It's a plus. Now the stretches are the same. So when you think about it, you still have the center at 1, negative 5. But after you have your center, both the x's and the y's are stretched by 3. So if you go out 3 units on each of them, you're going to have your circle with a radius of 3. So just so you recognize, if they're the same, it has to be a plus sign. Once there's a minus sign, it's a hyperbola. If it's a plus sign and those 2 numbers below there are the same, you have a circle with that radius, that stretch. If those 2 numbers are different with a plus sign, then it's an ellipse. You should be able to tell me the center and then know what your x stretch is and your y stretch so that you can give me the ellipse.